Okay, next news topic isn't really a news topic, but basically some of the GDC presentations from this year's GDC are now available on what they call the Vault, where you can actually access the historical database of all of the GDC talks. The new ones have been added, and Alex, you've been poring all over them. And I think this week you want to talk about Avatar Frontiers of Pandora, because there were, 3 presentations about the technology there, and we get an even greater insight into what makes that game tick. Because obviously we had our interview with the developers at launch, but this goes into way more depth.
Yeah, and I think in total there might have been 5 presentations. Wow. I didn't watch the sound one, but I read through it too. But I'm going to be talking today mainly about the ones specifically regarding ray tracing, and then a little thing about DX12 memory management on PC, because I found them all really fascinating. Now, at launch, we got a sense that they were doing a lot to get this game to run well. If you just look at it, it's like a super dense world with a lot of like procedurally placed everything, and you can barely see the ground like on the max settings because it's just so full of vegetation and scattered debris and all this stuff. It's amazing looking. Obviously, getting that to run performantly with ray tracing is a huge challenge, and getting that to run at 60 FPS on consoles is a huge challenge. And that's what the things in the presentation that really excited me. The first one that I want to talk a little bit is the presentation by Alexander Koshlo, which was about scene representation and custom BVH. In their interview with us, they mentioned how they are using, so on console, like on PC, you have a DXR spec, and all the BVH building, rebuilding, refitting is all done through proprietary means in the driver, and typically on the GPU from your respective hardware maker. AMD, Intel, and NVIDIA are going to do this in different ways potentially. And that's kind of like the room for innovation that DXR kind of wants to try and provide. But at the same time, you don't get that low-level access like you have on console. And on console and on PC, if you don't have a DXR GPU, they use a custom BVH, as they call it. So the geometry is more or less going to be pretty much the same between the DXR version and what you see there on the console version, but the way it's organized and kind of split up into these bounding volumes is going to be different. And they went through the decision-making process and why they did and what they did there. The actual details are fantastically cool. Like, one of the really interesting things that I thought is, like, on PC and in DXR and in the equivalent of DXR on PlayStation 5, for example, that BVH rebuilding, refitting, etc., bottom level and top level can be done pretty much only on the GPU, or on the consoles you have the ability to read an offline BVH from disk for the bottom level there. But here they do that reading from disk to save performance. But what they do is they do not use the GPU to generate top level BVH, or for things that are missing bottom level. They actually run that on the CPU, which is completely different than what we've seen in basically every other game out there. And they're kind of doing that to save most likely GPU time. But an interesting aspect of that presentation by Alexander was actually at the end of it in the question section, when someone asked, like, okay, why are you doing this? Which is a great question. And he said, it wasn't actually about performance. In the beginning, when they started prototyping these systems, because they wanted to get an RTGI system up and running on consoles, they had prototypes, but the question of like performance and how it's actually done are just completely different. Prototypes were most likely on PC hardware at that point in time. And at that point in time, and we actually heard it back then from developers, is that like the ray tracing APIs on PS5 and series consoles were just very early days. Performance, features, and reliability were not there. So they started to roll their own thing and then would hook it up to the system later on. And that's what they ended up doing and shipping with the game. So them running this like super custom loop of how to do ray tracing on consoles, it probably in the end will save them performance versus DXR on console, or whatever the PlayStation system is on console that is like DXR. But that wasn't the original reason behind them doing it. And I thought that was really fantastic to hear. So as part of the optimization for the game, I talked about it in my review, there's like a low kind of like quality to the geometry and materials in that BVH. And there's certain things that are excluded, like small grass and small plants, and a lot of skinned objects are missing. So like most character models would be not in there. And the reason why they do that is because they kind of wanted to save on memory footprint, because more geometry's in there, that's more memory that the game has to use. And if you're targeting things like 8 gigabyte GPUs or limited space on consoles, you can't just throw everything in there. And another reason why they said that is due to tracing time. So the more triangles that are in that BVH and all like the little nodes, the more time that the GPU has to spend testing against them potentially. And the denser the objects, the more it's times doing this, spending a lot more time doing the tracing itself. It's saving on memory and saving on trace time. And we've seen this in other games before, like Spider-Man, for example, is like one of the best, I think, examples of this on console, where you can see it really easily because there's so many mirrors in the game. In a game like Avatar, there's not too many mirror surfaces other than water, but it's usually like kind of displaced looking. So you don't see it too often. And in the rare moments when you do, you can really see how much lower res it is. And I thought that was just cool to see the reasoning behind doing it. Because in the interview, we kind of got a sense of why they would want to do it, but they explicitly say it there in that talk by Alexander. All right, so second talk that I thought was really cool.
Whoa. I still don't understand why they didn't just ship the console solution everywhere. Why did they do DXR as well if they already had the job done, essentially?
Well, so DXR 1.1 is going to give them other advantages on PC. One, they're going to get ray tracing acceleration. On console, they run the custom thing because there is a specific call in RDNA 2 to allow them to still use the ray triangle intersection units there, the repurposed TMUs, to at least do the triangle intersection part. But the traversal of the BVH and the existence of the BVH and how it is made and split up is all done custom. On PC, if you do, you can't get any of the benefits of hardware acceleration if you do your own thing, essentially. Right. And on PC, they want you to be able to do your own. They want to ship DXR to get that immense, performance uplift you'd get on something like Turing and pure, technically Intel hardware and all these other things. But as I said, they do ship this on PC if you don't have a DXR capable GPU, or if you turn off DXR, like I showed off in my video. So you can actually experience that console level look, because it'll have slight visual differences as a result of the way it's done. You can actually experience that on PC just without hardware acceleration, which is kind of cool.
Okay.
Yeah. Sorry to get ahead of myself there. You're right. Okay. Second talk that I thought was really cool was an optimized ray tracing pipeline for consoles from Quentin Quedlin. Now, this was cool because it showed off some images that Oliver is going to get here, and I'm going to send them to him. And it kind of shows off how they do their ray tracing, and it's how other games have done it too. Like, they specifically cite Metro Exodus as a big inspiration point. But originally they do a screen space trace, so it would be like SSGI at that point. But then if there's a miss there, there's high potential for that, obviously, because screen space tracing can only see so much and do so much. Then it goes into a world space trace where it'll hit that lower resolution geometry and materials of that in that BVH structure. But then if there's also a miss there or potential discontinuities, it'll fall back to a RTGI probe system, which is like DDGI or RTXGI at that point. It's an NVIDIA developed technology that we saw shipped in, I saw it in Dark Tide, as well as in the recent a remaster for The Witcher 3 on consoles. And these images that they show of like the way the game looks, if you only use like one or two of the systems instead of all of them together, is kind of cool. Like, they start off with this image right here, where, sorry, you guys can't see this, but the audience will. To start off with this image here of them combining screen space traces with just like the probe cache traces. And you can see there's like a lot of issues with it. And like some of the smaller things, like all the SSGI creates like overlap issues, and like there's like extra occlusion that shouldn't be there. But when they switch over to world space traces with probes, you can see that gets more accurate large scale detail, but it's missing all the small scale detail. There's none of the like extra occlusion on the ground, for example, from all the grass in the game, because that was just handled by screen space traces. And it goes to show you that even like if you're trying to get performance, like real hardware ray tracing, you're going to have to make compromises. And you have a holistic like grouping of techniques to cover a variety of ranges and different optimizations for each one of those to get it running better. And that's like another part of the talk that I really liked was the discussion like right at the end of it, showing off like some real performance figures between the various systems. Here's a little chart in there that shows Xbox Series X performance, Xbox Series S performance, and then an RTX 4080's performance at the same settings in the same scene while doing the probe update, which is like a more agnostic system that's not screen resolution dependent, for example. And you can see huge differences between them all. The RTX 4080, for example, completes the probe trace in 1/5 the time of the Xbox Series X. So that gives you a sense of how much faster this hardware is, and RTX 4080 is, regarding like what I would describe as simple ray tracing. It's like kind of diffuse, but it doesn't do a lot of other things that crazy path tracing does. So that's 1/5 faster. But if you look at the lighting time on that chart of Xbox Series X versus the RTX 4080, just like lighting the probes, it's like less than half the time there on the RTX 4080. So it shows that, yes, hardware ray tracing can give you benefits for like one part of a frame's aspect, but it doesn't necessarily help you as much as generic hardware does for another aspect of the frame. So the RTX 4080 might be for this specific thing in this game, like greater than 5 times faster than the Series X, but it's less than 2 times the speed for like the lighting of the probes. And this brings me to kind of like the idea of like when we talk about the PS5 Pro, that there may be mentions in those documents of aspects of the ray tracing. They say RT's like 4x faster, which is a huge range to actually say, but it may be describing one specific aspect of the ray tracing pipeline. Like here it's describing the entire trace loop. So, traversal, ray triangle, intersection, return, and obviously shooting the ray. But like for them, for PS5 Pro, it actually may be describing an even smaller step or the entire step. It's hard to know. So that's why you got to be careful when you describe things as being 2 to 4 times faster. I thought that was fascinating. And the last slide that I want to talk about from this presentation was actually about how they optimized it. They show a kind of, this graph here shows the Xbox Series X running at 1440p and quarter resolution ray tracing, which is how it's done on console. And it's just like quarter res, everything, no other optimizations in. And it's running there already at quarter res, 1440p. It's running at 15.2 milliseconds, which is just for the ray tracing. Like, you're not getting that game to 60 FPS at that point. So how do you get it to 60 FPS? Well, they bring in all these other things, like the screen space traces, the variable rate ray tracing for this screen space reflections, separate BVH and trace for the lighting structure. And then that brings them down from originally 15.2 milliseconds for just the ray tracing altogether, down to 7.1 milliseconds for the ray tracing altogether at 1440p on Xbox Series X. And the whole idea is that it should be leading to minimal quality loss, a lot of the things they're doing. And that just shows you just like the power of optimization. Yes, there is some quality loss in there when they're doing it, but they're trying to do it in a way so that it's less obvious to the user, and also getting quality wins for some other things, like the screen space traces are going to add to the quality quite a bit. So I thought that was fascinating. And something you don't usually get breakdowns of frame time on console in a lot of presentations. They're kind of afraid to talk about those things. So seeing it like directly in front of us was amazing. And then the last presentation, which a little bit shorter to talk about here, was DX12 Memory Management in Snowdrop PC by Gautier Viau. I don't know how to pronounce French names. I'm so sorry. Either way, really cool presentation. And the reason why I wanted to highlight this is because it's the opposite system of what we see in Nixie's ports. For them, for like Nixies, as I talked about earlier, they're comfortable with things going over the PCIe bus, and they're actually grabbing things in system memory that the GPU can use. And they're using that extra space to, for example, get like higher quality textures overall in the game. But it can lead to issues, as I talked about, like with the game's performance being thrashed. For Snowdrop, they do not want to do that, according to them. They essentially do not want to at all have a situation where performance can be possibly thrashed by going over the PCIe bus. So they spend a lot of time looking at memory management in Windows to prevent that from occurring, which is kind of like opposite of what Nixies does, where they want to explicitly allow that to occur. And the way they have it is that they in-game, and which is part of the optimized settings video, is that there's no texture quality setting in game. And that can be a bit irksome, but if they're doing it right, is not necessarily the case. And here what they do is if you don't have enough VRAM, they demote textures like on a MIP basis, like MIP per MIP basis that are like all collated together. So you'll get less quality loss, for example, in a game than when you have to, like, for example, in a Nixies game where you have to turn down the textures to all of them to medium for it to work. But in this game, in a game like Snowdrop engine games, it would only affect like a couple of the textures in any given scene. And we saw that actually back when I was doing my optimized settings video. One thing that I thought that was really cool there about how they do it is they actually use the tiled resources tier 2 implementation that was brought about by like DX12 and DX11. And you don't see it too often in games on PC because I think it's not too great for a lot of developers. They don't like the CPU cost it incurs. We've seen it in titles like, it might actually be in Death Stranding that I talked about earlier, but it was definitely in like the Gears of War 5 and 4 on PC, for example. But one thing that I thought that was really cool about them using this tier 2 version of tiled resources, a way to page in textures in a more fine-grained way, is at the end of the presentation, they mentioned that they want to improve on that system even more for their next titles, but also look at investigating sampler feedback, which is essentially a further extension of tiled resources as it was found in DX11 and DX12. And sampler feedback, as we all know, man, that was like the hype of the Xbox Series S before this generation started. How are they going to ship these games on Series S? And everyone was pointing at sampler feedback. And we've seen no examples or publications about its use at all in any shipping game. We've seen like demos. Yeah. There's like a 3D Mark benchmark that uses it, like, but no games. And once again, people cite the CPU impact that might have. Well, we'll see what that could be in a future Snowdrop title. So a lot to talk about there, but I think it's just fascinating to see behind the doors of one of the best looking games of last year, for them to break down the technology into such fine-grained detail, give it to other developers to potentially use in their games too, because they're building on the shoulders of giants. You know, they reference the Metro Exodus presentation quite often while doing theirs. And looking at the future, this sampler feedback thing, I would actually like to see it in a game to see what the heck it does, if it does anything at all. Yeah.
In theory, it should be a game changer, but I guess the fact it's not present in all hardware, modern hardware, does cause issues in terms of effort versus reward.
Yeah, I mean, by the time their next title ships, which is going to be Outlaws, I don't know how far along they'll be till then, but I imagine they're going to be doing this it could also be maybe in, gosh, the Division Heartland. Is that game still exist?
I think it's been.
Do you guys remember that?
Tom Henderson reported that it's been retooled, I think, a couple days ago. So,
okay, well, if that game exists, it could be one of the first times we see that. And by that point in time, you only have explicit RDNA 2 support on PC from AMD. You only have Intel Arc, and let's hope. No, they're not going to do it, but like stuff like GTX 1080 and 1080 Ti hopefully are just not at all found in a lot of systems anymore, 1060, etc. Mm-hmm. So they could actually potentially ship it in a title at that point in time in the future. The console, though, obviously you'd have it for the series consoles. You would probably maybe have it in PS5 Pro, but you wouldn't have it in PS5, so it's hard to know what they would ship there.
Yeah, that's an interesting point. It is an updated GPU in the Pro, and they do seem to have the full RDNA feature set, the full DX12 feature set, DX12 Ultimate, that is. And I think we've seen from the documentation that hardware VRS, for what it's worth, is in there.
Yeah, that's funny.
It would stand to reason that sampler feedback streaming is in there as well, right?
I'd hope so. If it's there in RDNA 2, the full one. Yeah.
I think what these presentations highlight to me is that this is just like the magic of GDC. I'm trying to think of another industry where professionals come together to basically share trade secrets.
Yeah,
and it's a net win for everybody in the end when you have this sharing of material. And it's not, they're not sharing code or anything. It's just general procedures and techniques. And it can be a game changer. I mean, basically Avatar deriving a lot of its work from Metro Exodus kind of makes sense, right? But there's going to be a lot of people looking at those Avatar presentations, and games will get better as a result. This is the magic of GDC for me. Absolutely fascinating stuff.
Ton of like little tidbits in there where they say like, this is like a dead end, don't go that way, or we had trouble with this, we did it this way, but it was actually another way. They presented like 2 alternative paths they could have gone, and they say maybe this works for your game. It's really cool.
Yeah, excellent. I watched a few of these presentations or skimmed through them, and yeah, the ray tracing presentations I thought were the most interesting, specifically on their console RT, because like you see how heavily they depend on screen space tracing and how like expensive the denoising is. And they even showed at one point the pre-denoising and post-denoising RT results, which I thought were fascinating. Like you see, again, just how low res that underlying RT is. They're getting such a good result out of it when they combine the probes, the screen space tracing, the RT, all together. They're actually getting a really good result with optimizations like you said, the variable resolution of the RT reflections, and all the stuff they're doing in screen space. And it's just really impressive to see the final result come together after all those tweaks and all those optimizations to actually achieve a good looking and performant result on a console. It's just super, super impressive.